Let's go over what we talk about in the lecture. First, we talk about the concept of identities on Bitcoin network. In Bitcoin, each node's identity is represented by their public key. However, ultimately, the public keys are controlled by the owner of the private keys, and only the private keys can be used to spend the money. And another thing to note about identity is that users can generate as many private public key pairs as they want. And how does that work again? Remember that there are 2 to the 160 total possible private keys, and it is extremely unlikely that someone might happen to generate the same private key as yours. Nor is it at all likely that someone can just guess your private key to spend money on your behalf. Bitcoin doesn't have the account balance model that banks have. Instead, users spend outputs from previous transactions. These specific outputs are called unspent transaction outputs, or UTXO. The total value of Bitcoins you have is the sum of all of your UTXOs. And these UTXOs are uniquely identifiable. They make tracking payments at the protocol level much more straightforward, because the UTXO record system makes it easy for nodes to see how funds have changed hands between users. The UTXO model might not be the most intuitive model for us to understand, but it works well for Bitcoin from an architectural standpoint. As we mentioned earlier, the blockchain is the key data structure for record keeping in Bitcoin network. New transactions are recorded with new blocks added to the existing established chain. Once a transaction is recorded, it is closely impossible to undo it without changing every single version of this database in the universe. Therefore, we say that blockchain is an immutable and tamper-evident database. And the last concept that we went over is consensus. Consensus is the way that the entire Bitcoin network comes to agreement about a single version of transaction history. How does it work? Proof of work requires that voters expend a considerable amount of computational power in order to validate transactions. But why do we need proof of work? Because there's no central authority to make sure that one person only votes once, and there's no limitation on how many identities each of the users can generate. Bitcoin uses computational power as a resource constraint to limit the voting power of malicious entities. Proof of work makes voting expensive for everyone, so that the voting power a person has is based on how much computational power they have, instead of based on the number of identities they can generate. Given all this information, you can now justify many of the common buzzwords associated with Bitcoin, which you may have heard. The most common descriptors of Bitcoin are pseudonymous, decentralized, immutable, and trustless. And let's go over what each of them means. Pseudonymity is a combination of the words pseudo, meaning fake, and anonymous, meaning unknown. Bitcoin attempts to be anonymous through having every user represent themselves with a random number, the public key. However, because it's not impossible to trace back these virtual identities to real-world identities, Bitcoin is not completely anonymous. It is only mimicking anonymity. In Bitcoin, addresses and pseudonyms are synonyms. It is a fake name, but it can still be used to trace back to your real identity with enough effort. In addition, decentralization refers to taking an activity that is typically performed by one central entity and repeating the storage of information and computation among more than one party. Bitcoin achieves decentralization by having every single participant on the network store the full history of transactions, as we have seen. This way, every user possesses a copy of the transaction history and does not have to ask anyone else for that information. Immutability, referring to the inability to change information, is another property of Bitcoin achieved through decentralization. Once all users in the Bitcoin network decide on the validity of some transaction, it is extremely difficult for anyone, including the users who make the transactions themselves, to undo their decisions. This feature helps foster trust among nodes on the network. If one wanted to alter the history of transaction, they would have to change every single user's local history simultaneously, which in the present day is close to 10,000 different users. As a result of these three properties of Bitcoin, pseudonymity, decentralization, and immutability, we achieve in Bitcoin a trustless environment because every user is by default a stranger to everyone else. Then one might ask, how do we trust others in this network? If we don't trust a majority of Bitcoin users, how do we trust Bitcoin? Well, the Bitcoin protocol ensures that one does not need to trust their peers in order to be certain that any transaction they make will be accurately recorded by the rest of the Bitcoin network. First, the ledger is publicly verifiable. Anyone can see any and all information about the transaction history in Bitcoin. You can go to the blockchain and check if your transaction has gone through. In addition, the Bitcoin network is secured through the Proof-of-Work Consensus Protocol designed by Satoshi Nakamoto, which changed the way everyone thinks about currencies. Therefore, these are the four essential unique properties of Bitcoin: pseudonymous, decentralized, immutable, and trustless.